Okay, so here we go. This is the last section is chapter 7, scale drawings. Um, and basically this is about how to read a map. If you're given a map, how to find, how far something might be on the map, or if you're given, again, like a scale model, like a toy car or something like that, to talk about how big it would really be if you know how it compares to its original figure. So we've used scale factors to solve problems in polygons before. Now we're going to talk about scale models and use scale factors to solve problems. So here we go. First thing, scale model or scale drawing is an object or drawing that with lengths proportional, okay, to the object it represents. So here's our definition. Do this in green. It's an object or drawing with the lengths proportional to the object it represents. That's close enough. There you go. The scale of the or a model, the drawing, is the ratio of the length of the model or drawing to the actual length. So again, just like back in the check section before, length of the model of the drawing to the actual length. Again, that's the same thing as we had back in the previous section. New length, which is the model, to the original. Okay, new length original, or model to real. However you want to think of it, that's how it's set up. So that's how scale factor is determined. Okay. So here's our first example. We've got a map here, okay, of Nashville. Now this is kind of out of date because anymore, hey, GPS, just throw it in there and go. But this is an old-fashioned skill that works with similar figures and scale factors. So right now, the map is telling us that 4/10 of an inch is equal to 40 miles on the map. Okay, so if I could find a distance of 4/10 of an inch, I'd have 40 miles. Now the problem is asking me, how far is it then from Nashville to Chattanooga in Tennessee? Well, the first thing I have to figure out to do this problem is how far is it from Nashville to Chattanooga on the map. So if you've got your uh, uh, textbook with right now and your ruler, you could just take a ruler and measure it out and see how long it is. We'll do this in class. For me, I've already done it and I screen captured it, took my safety compass, and sorted out how long it was. Now the problem I ran into is twofold. Hopefully this comes out. One is the paper in that part of the book is bent, so that's why in class tomorrow we'll use worksheet. But two, I also couldn't fit my ruler with the 1 inch in here and the or 0 here to 1. If you look really closely and you kind of zoom in, you can see this says 4 here and this says 3. So I'm actually using the other side of my safety compass. And so I got to figure out how far is it from Chattanooga to Tennessee. So I lined up what I could with Chattanooga, the bar right here in the end. I'll do it in red so it stands out a bit. But right here, and I'll make that a little bit thicker if I can. Let's go a little thicker. There we go. So right here, starting there, that's where it's starting at. That's the 4. Now I got to figure out then, hey, I'm ending right here. So how long is it on the ruler? Well, you have to know how to read a ruler and know that the small marks on it, the little marks here that barely you can see, every mark they have from one to the next is 1/16 of an inch. So this is, if I now kind of mark on it, this is 0, 1/16, 2/16, 3/16, 4/16. And 4/16 is a quarter of an inch because that little bit longer mark there means quarter inch. So I got 4/16, 5, 6, 7, 8/16, which is a half an inch. Okay. And then I'm sorry, I marked something wrong earlier. I apologize. This is not what I'm looking for. That's Murfreesboro. If you were looking, hey, why did I mark that? That's Murfreesboro. Here's Nashville up here, which is what I want to know. So that one actually, I apologize. Should have made that a little bit. That's the dot I'm looking for. So right there. So anyway, back to my marking. Okay. So again, 1/16, 2, 3, 4 is a quarter of an inch. 5/16, 6/16, 7/16, 8/16, half of an inch. 9, 10, 11, 12/16. So we're talking now 3/4 of an inch. 13, and then about here, finally we hit, that guy's about 14/16 of an inch. Which, 14/16 of an inch is actually equivalent to, if I reduce it, 7/8 of an inch. Okay. So that's how far it actually is in my map. Again, roughly, it's not perfect, but I had a kind of, again, curved piece of paper, and I had to kind of go backwards with it. But it's 7/8 of an inch. Now, to figure out how far I traveled, they've given me the scale. 0.4 inches equals 40 miles. We had 7/8 of an inch. We want to know how many miles is that. So here we go. 0.4 inches equals 40 miles. 7/8 of an inch equals how many miles? Well, there's my proportion to set up. 0.4 over 40 equals 7/8 over x. And this is perfectly fine to just leave it like this, because I'm just going to cross multiply. I'm just going to go grab my calculator to do that. So I can do on the calculator 7/8 times 40. And when you do on the graphing calculator like this, you have to do fractions in parentheses. So I get 35. And that equals 0.4x. Okay. And then divide by 0.4. So 35 divided by 0.4. Which gives me 87.5 miles. Again, that's just a rough approximation. It doesn't actually have to exactly be 87.5, but that's what I got from my work here. So how far is it? 87.5 miles by the map. Okay, great. So that was that first example. Next couple work a little bit faster. Okay. All right, so scale model. Mrs. Alejandro's history class, this is number 2 in the book, made a scale model of the Alamo that is 3 feet tall. The actual height of the building is 33 feet 6 inches. So the question is, what is the scale of the model? And then B, how many times as tall as the actual building is the model? How many times as tall as the model is the actual building? Well, in order to figure out the scale, okay, you are comparing the two. And it's always model to real. So model to real. And in our case, Mrs. Alejandro's history class made a scale model of the Alamo that is 3 feet tall to the real one that is 33 feet 6 inches. Okay, so that's part A. And we'll deal with that now. So model is 3 feet, real is 33 feet 6 inches. I don't need my calculator anymore. All right. So that's what I'm looking to figure out. Okay, how is the scale this? Well, what you really want for a scale is you want 1 to something. Okay, so in our case, we want 1 foot to whatever this guy would be. And this one's a little trickier because of the mixed units, but we can kind of cheat in this case and say, okay, well, if I have 3 feet to 1 foot, I could divide both of those guys by 3 to get from 3 feet to 1 foot. Now, when I do that, 3 divided by 3 is 1. This guy, I divide both of them separately, and luckily for us, they are actually both divisible by 3. And 33 divided by 3 is 11 feet. And 6 divided by 3 is 2 inches. Okay. So for our scale, which I'm actually not done yet because I don't like the way this is written, but this is kind of just a rough idea. 1 foot equals 11 foot 2 inches. Now my big problem with this is the fact that this guy is kind of mixed units, feet and feet to inches. So what I'm going to do is convert 2 inches to feet, which isn't as bad as you'd think. It's not perfect, but 2 inches compares to 12 inches because there's 12 inches in a foot. That's 1 over 6. So my real scale is 1 foot of our model represents 11 1/6 feet of the real Alamo. And that is a much better way to write that scale out. 11 feet 2 inches might be easier to sort out in your head quickly because you're like, okay, 11 foot plus a couple inches. But now I've gotten this set up so that it's 1 to something and not weird mixed units. Now that's part A. Part B then asks us, okay, how many times as tall as the actual building is the model? Well, we've already figured that out. That's the scale. If I wanted to know how tall it is, what I would do is take the building and multiply it by this guy, and so that's part B. I would multiply the building, or sorry, the not building, the model is 1 to 1 and or 1 to 11 and 6 times as big, which seems weird because it means it's smaller. Since this is less than 1, it means it's a lot smaller. Now the other question is, what is the building? Well, the building, the real, is just the reciprocal of this. It's flipped. Is 11 and 1/6 times to 1, which is really 11 and 1/6 times as big. Okay. Which means for us, if I were to take anything on the model, anything at all, I'd have to multiply it by 11 and 1/6, and I apologize for the bad hand. That's a little better. I would have to multiply it by 11 and 1/6, and that would give me how big it really is. So if I had, hey, there's a flagpole out in front of our little model. It's an inch. It's 1 inch, or 1 foot. Actually, 1 inch would be fine too. How big is it? We'll multiply it in real life by 11 and its sixth. It's really that much bigger. So this is just kind of a brief overview of a couple problems. We're going to get more in depth in this class. It really takes more measurement and takes more fraction work. So if you got any questions, again, come on in, and I will sort of thing out for you. We'll go through it in class tomorrow. All right, great. Thanks. Bye.